Okay, hello everyone. I hope you can see my screen. Um, I'm Vincent Schoonderwood. I'm one of the imaging specialists at SVI, and I'm also responsible for the marketing. And this day we're going to talk about the image and batch feeder, how to directly link through Huygens deconvolution to your images and to your microscope. So the image and batch feeder connects folders of images to Huygens, and Huygens can spit out images that are deconvolved in an output folder. We can do the connection to these images via the image feeder and batch feeder, and I will explain in the following slides what the difference between the two is. So basically, the image feeder opens new images directly in Huygens. If you save an image upon acquisition into a folder, you can open that then in Huygens, and then you can continue working with this image. So that can be newly acquired data on the fly, opened in Huygens. We have also two packages with which we collaborate, the Iberia instrument acquisition software and Leica. They have a button that says send to Huygens, and then the image is opened in Huygens. In the Leica case, people also may have the exchange option where the image is again being sent back to the Leica software. So doesn't need to be newly acquired data. You can also load the complete folder of images. So all the images that that folder contains, even images that are in subfolders. The batch feeder, on the other hand, opens the images in Huygens, but also immediately lists them in a queue and processes them with deconvolution. And that can be done on the fly. So meaning that if you have a newly acquired dataset just saved in a folder, the batch feeder will monitor that folder, will recognize a newly entered image, and will add that to the queue for deconvolution. What microscope types we support? So basically any microscope type. And that also means that we support a lot of different file formats, more than 30, and the most vendor formats are included in the full file reader option that you can include in Huygens. So the deconvolution of every image in the batch feeder, this is essential, is optimized, like with Decon Express. So the signal to noise ratio is estimated, the background, the proper deconvolution algorithm is selected, and based on that, you get the most optimal result for your images. Meaning that the images should be acquired properly in order to get the best result with the batch feeder and with Decon Express. If you need further tweaking on the deconvolved data or to deconvolve the data, you can use, as you may know already, the wizard in the Essential or Professional, the operation window in Professional, or you can use the Huygens Remote Manager in combination with the core, which is its web interface. And if you want to treat images similarly, then you may not want to use the batch feeder or the Decon Express, but you want to treat them similarly using templates. You can use a fixed microscopy template and a fixed deconvolution restoration and or analysis template. Use these in the workflow processor or in the Huygens Remote Manager, and off you go. So where should these folders be located? The watch folder of the image feeder and the batch feeder can basically be located on any computer. If we that can be on the computer on which Huygens is already installed. So you have your watch folder with the input data and the deconvolved output folder. on the same machine or on a microscope, but you can also save from the microscope to a folder on the Huygens computer, and that one is being watched and deconvolved. You can also save the data on the microscope computer in a watch folder, and then Huygens monitors over the network that watch folder, extracts the images from there, deconvolves them, and saves them to the output folder. Then the folder structure can be preserved. So the way the folder of the raw data is configured can be kept in the deconvolved output folder structure on the server. And we can even have different setups with, for example, Huygens Everywhere, which is kind of a basic floating license that multiple users use on their computer, Huygens Everywhere. They connect Everywhere with a folder on the microscope that they use for their images, so they get their deconvolved data on their own computer. And that can even, of course, be done with multiple microscopes. You can connect two different microscopes and extract the images from there onto your output folder. So I like to show you a demo of our software. Give me a second, take some water. So let's see how this works. So I have here a folder of images that are pre-made. There are 3 images in there directly in the root of the folder, which are abbreviated ICS, so that's the file format, and HDF5. So this is the Huygens HDF5 format, and the ICS2. ICS2 is open source. It's a file format that we really strongly encourage users to use. It's open source, can be read by Fiji, ImageJ, or Imaris. We support it. It's future-proof, can deal with 32-bit float, and can contain the metadata, so it's not lost. If you save a TIFF, you will lose your metadata. And these subfolders also contain images. So here is a multiphoton dataset of organoids, a delta vision folder with 2 delta vision file formats, different formats. We have here an Olympus VSI file. We have a stat confocal dataset of a Barrier OBF file and a Leica file, a LIF. And we have here a size LSM file. So we are going to load this content in Professional. I've already set the image feeder in such a way that it reads the images from this folder. So if we start Huygens Professional, just need to wait, and then the images are loaded. You see that these are not all the images. These are only the 3 images that are directly in the root. I like to show you now first, if we drag and drop an image into the folder, that we show that Huygens reads it on the fly. So this is my image folder, and I'm just imaging a image on a Nikon system, and it's being saved in my folder as an ND2 file. And you will see in a second that this image will appear in the main window, aside from the images that were already opened. Then in the meanwhile, I'm going to the Edit menu, looking at the preferences. And if I do that, I can configure this image feeder folder. And if you look carefully, you see that that ND2 file has appeared in my main window. So under Edit Preferences, there is an image feeder tab, and this image feeder tab allows me to activate the image feeder, deactivate it, or activate the batch feeder. So in many licenses, this option is already present. You can just have a look and see whether it's functioning in your license. If not, contact one of our account managers, imaging specialists. So I've activated, as I mentioned already, the image feeder. It has a standard mode, so it works well. We have an Iberia image feeder, and the Aurochs image feeder is work in progress. So we can connect also to these specific feeders. Then the image folder that I want to read my data from, that's on my desktop, and I can just change that as well if I want to. Then here it says load the folder content upon startup. I did that. You saw that the images were opened during startup of Professional. If you don't want that, just uncheck it. And here is the recursion depth. And if I hover with my mouse over these lines, you get an explanation here at the bottom of what it concerns. And if I increase this to say 5, I increase the number of levels of subfolders that Huygens looks into for data. So now I hit apply. I say proceed, save my preferences, and now all the images from this folder, also the subfolders, will be read in. This can take some time, and if you're a bit impatient like me, you can go to Tools and click on the Refresh Feeder button. So this has been added to the latest release, and you see that all the other images are opened as well, including the Iberia stat.obf file, which also contains tiles. That is why Huygens is asking you to stitch these tiles. So I say yes. Here I see the content of this OBF file with the tile images. I can select them holding my Shift key, say accept, and then Huygens automatically opens the stitcher. And I'm not going to explain all the steps. My colleague Melvin did a wonderful job in explaining that in the previous webinar. So I welcome you to have a look at that stitching webinar. It's recorded and on our website. And if we just continue, we stitch all these tiles together. And we have the mosaic file in a few seconds in the main window. Okay, so now it's done. Here is the stitching file. So with these images, I can, of course, work with all the different tools in Huygens, like deconvolution and restoration. I can apply a quality control check with the quality control tool. I can perform analysis, visualization, etc. So for now, I'm going to the Start menu, say Close All. So all the images are closed. And I want to explain to you now the batch feeder. So we go to the Edit menu, Preferences, Image Feeder, and we select the batch feeder. Here we select the folder, My Images, so I need to go to my desktop and go to my folder, My Images. It's the same folder as what we had with the image feeder. I hit OK. Then the output folder, I have that selected here, and you see it's empty. Then here, the recursion depth, set this to 5. Do you want to preserve the folder structure? Yes, so I've checked this. I've also checked that it needs to start up when I start Huygens Professional. That also works for Essential, by the way, if you have that package. And here, the deconvolution strategy, you can specify that as well. I'm working by default with standard, and that's fine. So these are the same strategies as deconvolution express uses. So we hit apply, we hit proceed with saving, and it says here that we need to restart in order to activate this. So we close Huygens, and we start it again. Okay. And you now see that the batch feeder immediately starts with a list of images that it reads from the folder, and it also starts deconvolving them. It shows you previews of the raw and the deconvolved version, and at any point you can pause the tasks. So I do that now. Stop it, and I can also rerun it, and then it starts where it has stopped. And if we move to the next image, I pause it again. Okay. So now it's stopped here. So I have the time now to explain a bit more about the window. So you can click on an image that has already been deconvolved, and you see the before-after result. So that can be seen of the different images. So I can specify here my watch folder, which I did already in the preference window. So it's kind of the same. So you can overrule the folder, here the output folder. And there are already images in there because we already deconvolved some. There's a refresh button, so if we add images and they don't appear yet, we can refresh this. We can delete images. So suppose, for example, here, we can just click on an image here on the left and say delete. We can do that with multiple images. And what we also can do is we can select many images. And let's see, which ones do I select? Well, quite some, because we don't want to work through the whole list of files. Okay. And if I now click on ready to run, I will basically deactivate all these tasks. I can reactivate them. I can also deactivate them. And I can also unselect all the files and just reactivate them one by one. If I click here on the status, they are reordered with the ones that need to run at the top. So Huygens will skip these and continue with this one. So in this sense, I can prioritize certain images. So what I'm going to do now is I will add another image to this folder. Let's suppose that is being saved by the microscope as I'm just imaging right now. So I'm adding an OME TIFF file, and you will soon see that it is being added as task number 20 at the bottom of this list. We can save all the files to different formats. Select the one that you prefer. And as I mentioned, ICS2 would be a wonderful choice considering the metadata that it can contain, the compatibility with other softwares like Fiji, ImageJ, Imaris, etc. We can change here the preferences, kind of overlapping with the possibilities we have in the preference window. Here at the bottom, it's listed what my watch folder is, what my output folder is, and it says here I'm waiting for new images. And that also brings me to that this lung organoid OME TIFF image has been added to the queue. So Huygens is constantly monitoring my watch folder for new data. Then the RAM here is indicated how much is being used when we process data. And here we have the standard profile mode for deconvolution. So let's run the tasks again. Well, I want to skip this one, so let me pause it and say stop, because this takes a bit of time, this VSI file. Okay, so I'm deactivating this one and I'm continuing with the Leica statcom vocal data. Okay, so here is a progress bar at the bottom. Huygens also indicates the peak of RAM use. And now we're all done. So we can stop this. We can select one other file that we want to look at for results. And here we have different options. We have here a tools menu. We can open the file manager and see where the result is located. Now the window pops up behind my batch feeder window. So here is my deconvolved result of this file. And it's in the Leica folder, statcom vocal, output data. And you see that my output data, my structure of folders is conserved. I can also open this image in Huygens in the main window. I can save a deconvolution template. I can edit the parameters. And what I can also do is open the twin slicer with this. That button is here. Oh, yeah. Okay, this is an image with just a few slices of information in the whole 3D volume. So I'm slicing through it, and you see the improvement that it gives. Also along Z, because you see the autofocus light being corrected. And if we set this to MIP, you also can see clearly the improvement. And what we can do immediately is right-clicking with my mouse, say Analyze, and start the Object Analyzer. And then you see that this image is nicely segmented because of deconvolution and the signal increase that comes with that. And we can very quickly analyze all these small structures by deleting these large ones, just moving them and saying Analyze All, and we have already all the parameters of these small objects. Okay, so now I want to delete all these files. So I can do that with this button. And I want to show you how a TIFF series is loaded. So I'm going to change the watch folder from my images to a TIFF folder. And this folder of TIFF images has several Z slices and 2 channels. Okay. So it's a TIFF series. We only need to select the first image, and then Huygens comes up with a warning. This is a TIFF series. Beware that the metadata is probably not available. But we can work on that. We can also define here how such a series should be read. So in this case, the Z dimension, those are slices. The CH channel dimension are in fact channels, but we can ignore this or keep this as a separate image or set this to time frame, whatever is applicable. Save the settings, and now we can run the task. So this is an image that is DAPI stained. You see the clear nucleus and also peroxisome. So it's a 2-channel image, but we actually see 2 green channels, and this is suspicious. And notice this was a stiff image, so it may be that the metadata is not correct. So what we can do is right-click on the image or use the Tools menu and select Edit Microscopy Parameters. So this is one of the most important windows in Huygens. It checks whether your metadata is correct. So in this case, the sampling is correct. It has nice green bullets saying value was obtained from the metadata and is trusted, but the numerical aperture is not correct. Then the lens and embedding medium are not read from the file. They are also colored orange, as well as the channel label, but also the excitation and emission wavelengths. And both channels are set to wide field, whereas this is in fact a confocal channel. So we can change all this and change the wavelengths and save this template for use for this type of data. So if I have many of these simulative data sets, I can load a template file, and I'm going to do that now. So I say the microscopy parameters, I want to have them overruled. Oh, then I first need to stop the task. I want to have them overruled, all of them, and I select a template file from my TIFF series folder. So I have here the microscopy template file that was corrected. So you can also overrule only the estimated values or overrule the default values and keep the others that are coming with the file. But we will overrule all the metadata. And if I now say run task, then I need to stop it first and reactivate this. Sorry, I forgot. Ready to run. I say run task again. And now you will see in a moment that we have a nice DAPI nucleus and some peroxisomes. And if we then look in the twin slicer at the results, you can clearly see, if we see the map, what the improvement is with Huygens. Okay. If we have a multi-channel data set like this one, we can also activate the chromatic aberration corrector, control for any possible shifts, and perform a co-localization analysis if we want to. So I'm closing the batch feeder. And I just want to show that you can also start the batch feeder from the start menu or from the deconvolution menu. So you don't need to run it on the fly with Huygens if you start Huygens. Okay, so let's go back to presentation mode. So I want to mention that we have a webinar coming up, a few webinars. So we have a webinar schedule here. The one that's coming soon in March is again about Lightsheet, but more or less an overview of all the Lightsheet tools that we have in Huygens and the new parameter user interface where you can align the sheet, the focus of the sheet in relation to the real image. So you see here that the point spread function becomes narrower in this part, and at the side it is wider, and that fits with kind of the setup like this. And in April, we have a free online 3-hour workshop for people who getting started with Huygens and who are interested in seeing what the relevance of deconvolution and image restoration is. Okay, so feel free to spread this news, to ask for a trial license, to test Huygens. And if you have any questions, you can raise them now in the chat. And if there are no questions, I want to thank you for your attention, for joining this webinar. And I hope to see you the next one. Have a nice day and see you at our next webinar or workshop.